Hello everyone, my name is Youngjung, Principal Solutions Architect in AWS.
Hello, my name is Sudhir Sheth, Principal Solutions Architect at AWS.
At MWC 24 last year in AWS booth, we had introduced very interesting GenAI use cases for mobile network operation, featuring prediction-based smart scaling and closed-loop orchestration-based smart healing. And this year, I'm very excited to introduce another powerful showcase of the GenAI for the network operations, which is coming through our working backward principle done by one of our customers' journey. The live trial of our customer Telus, we were able to demonstrate significant benefit when we move the network functions from physical data centers to cloud. It can reduce down the read time of the data center preparation from months to weeks or days. But we still identify that there is some more points we can optimize better. And then because there's some challenges remains in the time and scale for generating the code for infrastructure, and also and then especially when the environment would be composed with multiple vendors will be present their own orchestration tools and then their own style of the format of the packages. That makes operator to have a difficulties to have a common pipeline of the deployment, and then that the aspiration of our telco customers that remains to have a vendor agnostic and also the unified orchestration platform with having just only minimum input from vendors like a high-level design document and low-level design document. That leads us to think about this new approach. To solve this problem, we thought about using GenAI, how we can make GenAI to help these people, operator, human operator. And we built three component systems. The first is a chatbot interface using a SageMaker Unified Studio. And the second system is the core of the service, Bedrock, which is providing LLM and the knowledge base, which is RAG and the agent functions. And using this, we can generate the code for the infrastructure and change the helm values.yaml file using the GenAI from the documentation information. And then we built LCM systems using the GitOps pipeline and AWS serverless services like a Lambda and API gateway. And next, Sudhir will show you high-level architecture of systems and a quick demo.
Thank you, Yang. So this is the high-level architecture of our solution. On the top portion, we have the generative AI components and solution, and in the bottom, we have the GitOps solution. As you see, we have Amazon Bedrock components which make up the generative AI solution. In the front end, we have the Bedrock IDE provided chatbot application, which is front-ended by a network operator who would use natural language queries and chat with the chatbot to generate the artifacts. In the back end, we have Amazon Bedrock providing several LLM. In this case, we are using Anthropic Claude Sonnet v3.5. Amazon Bedrock also provides a knowledge base where all of the artifacts from the customer and the vendors are stored. Basically, the LLD, the low-level design documents, the high-level design documents, the CIQ, and the user guides that are provided by the customer and this thing, which is stored in the storage. Amazon Bedrock then chunks this information and stores it in Amazon OpenSearch serverless vector database. Once the network operator chats with the chatbot to generate these artifacts are then passed as payload to the APIs via API gateway through to the Git system to provision the infrastructure via the Argo CD based CI/CD solution to provision the AWS infrastructure. Once the AWS infrastructure is provisioned, network operator would again use natural language commands to instruct the bot to deploy the network function on top of the AWS infrastructure that was just deployed. Now we'll take you to a quick video which demonstrates the overall solution. This is the Bedrock IDE chatbot interface where we have a knowledge base with all of the documents stored, and we also have a function definition of all the APIs that are called to the backend GitOps system. Now a network operator who is in front of a chatbot would use natural language queries or commands to inquire about the network. In this case, he's asking to provide details of all the AWS resources that are needed to deploy a Samsung P gateway on AWS. As you see, Bedrock provides a detailed summarization based on its learning of knowledge base information stored in the knowledge base of all the resources, AWS resources that are needed to provision a Samsung P gateway. Now, operator could again go about asking follow-up questions to get more details of the configurations and provide more. As we discussed that our knowledge base has multiple vendor information. Now the operator is asking details of give me details of what is needed for NG Voice IMS, and Bedrock is providing additional detailed information of what is really required to deploy NG Voice IMS on AWS. Now, as the operator feels confident about deploying the solution on AWS, he could then command the bot to generate detailed Terraform scripts and artifacts, which will then help us deploy the solution on AWS. Once the operator could then review each of these templates, suggest changes if needed, again using natural language commands, and once he feels confident, these artifacts could be then published to Git. The operator could then again use natural language commands like publish these files which contain the actual detailed artifacts. These commands, these natural language commands are translated to Git commands, where the actual content, the Terraform files that are generated by Bedrock are passed as payload to the APIs and published to the Git. As you see here, Bedrock has now called API to publish the artifacts to the Git. And you would see this is the Git front-end graphical interface. On refresh, you would see that the files have appeared on Git. Argo CD is our CI/CD framework where it picks up the files that are generated and starts provisioning of AWS infrastructure. On completion of AWS infrastructure creation, the operator would then go about deploying the application itself. In this case, we are demonstrating that operator would go about deploying a free 5GC open source application on top of the AWS infrastructure that was just created. This would again create another CI/CD pipeline which shows the deployment of the application. In this case, we are demonstrating 3 different applications which are deployed here: free 5GC open source 5G core. We have NG Voice IMS and also the Samsung P gateway also deployed on top of the AWS infrastructure that we just demonstrated creation. Also, this is deeply integrated with all of our observability solutions, Amazon CloudWatch and so on. So all of the clusters and the Kubernetes infrastructure that was created as part of the AWS infrastructure creation can be visualized in a beautiful manner for all of the observability and monitoring requirements. As an outcome, what we demonstrated is you could use Gen AI to build a unified infrastructure provisioning solution, irrespective of vendor agnostic solutions and so on. And we use serverless components to automate the overall lifecycle management of the solution. Overall, we also used GitOps-based intent-driven provisioning vendor agnostic solution for the infrastructure and network function deployment.
Thank you.
Thank you.